Please don't forget to like, subscribe, and comment. Thank you so much.
Join us at Like Learning School and experience a transformative education journey. Visit our website at www.likelearningschool.com or contact us at +234 808 509 5144 to learn more and get started today.
So, differentiation, essentials, and applications. The general rule is this: if you have y equal to ax raised to the power n, and you're asked to differentiate y with respect to x, like if you're asked to find dy over dx, the term is differentiate y with respect to x. Differentiate y with respect to x. You simply multiply the power of x by whatever coefficient of x you have here. What's the power of x?
N.
Good. The power of x is n. What's the coefficient of x? A. Okay, so you're going to multiply the power of x by the coefficient of x, so it becomes n times a, or an. Then that x, you will now subtract the original power, take away 1 from it. You know all of that, isn't it? So,
Yes, sir.
okay, so it becomes an x raised to the power n minus 1. First of all, you take the power multiplied by the coefficient of x, it becomes an. Then the x itself, the power, remove 1 from it. Simple example. I hope you can see what I'm writing.
Yes, sir.
Simple example, if you have y equal to 5x raised to the power 3 minus 4. Do you know that this 4 is the same thing as 4x raised to the power 0? What is anything raised to the power 0 is what?
1.
1. So 4 times 1 is the same thing as 4, isn't it?
Yeah.
I'm just trying to tell you that 4 is the same thing as 4x raised to the power 0.
Okay.
Okay, fine, this is what I want to do. 4x minus 5. Let me write it as 4x. Then minus, or maybe plus 5. What's the power of this x? This x and 4x. Pardon?
1.
1. This x raised to the power 1. What's the power of x here? This,
Nothing.
you can say 0. It's like x0 or no x at all.
Yeah.
So I don't bother you with that. Whenever you have a constant and you differentiate, the constant will disappear. So let's not just disturb ourselves with that. So let's differentiate this. So we're going to find dy over dx. And I said, bring down the power. 3 times 5. That gives us what?
15.
15x. 3 minus 1, 2. In other words, 3 times 5, 15. Then the power, you remove 1 from it, like we did here. So it becomes 15x squared. Now what about the minus 4x?
Minus 4.
Minus 4, because by the time you do x raised to the power 1 minus 1, that will be 0, so no more x. What about the constant?
It goes away.
It goes away. Okay, so this is the coefficient. All right, let's go to the next page. I'll be scrolling to the next page. Anyway, this one is obviously, if you have y equal to 3x squared minus 5, you just do 2 times 3, 6, 6x. The power is 2, then 2 minus 1 becomes 1. So it's simply 6x. Are we right?
Yes.
So 6x. The constant disappears. Okay, how about this one? This is 5 over x cubed, right? By indices, is the same thing as writing, or let me write it like this: 5 times 1 over x cubed. I hope you know that's what it means. Because 5 times 1 over x cubed, is it not the same thing as 5 over x cubed?
Yeah.
Now 1 over x cubed in indices is x raised to the power minus 3. So this is something I say 5 times x raised to the power minus 3. Or simply 5x raised to the power minus 3. 5x raised to the power minus 3. This is the same thing as this. This is the same thing as this. I hope you're seeing it.
Yes, sir.
Okay, that's 5x raised to the power minus 3. So let's differentiate it. What will it give us? Let's do the y over the x of it.
Minus.
Yep, I like that. Minus 3 times 5, isn't it?
Minus 15.
Beautiful.
X.
Like, lovely. So the y over the x will be minus 15x. Minus 15x.
Yes, minus 5.
Do you mean minus 3 minus 1?
Minus 4.
Yeah.
Yes,
The power you have to still take away 1. That's minus 3 minus 1, which is minus 4.
Yeah, that's minus 4.
Minus 4. If you like, you might want to write it as this. It's still the same thing as saying 15 over x raised to the power 4. Okay, let me zoom it out a bit so that you can see it better. Oh, I should have zoomed this thing out much bigger. I know you're using a smaller gadget, so I hope you're seeing it better now.
Yes, I am.
The way it was earlier, were you seeing it at all?
Yes, I was.
Okay, so I'm saying minus 15 raised to the power x, minus 15x raised to the power minus 4. This x raised to the power minus 4 is the same thing as taking it down, and it just becomes x raised to the power 4. Just like the way we had it initially.
Yeah.
Alright, let's move on. These are topical questions. Differentiate 6 plus 4x minus x squared. Let's go very quickly. The y over
Minus 2x.
the y over the x will be. Go ahead.
Minus 2x plus 4.
Or 4 minus 2x. Is that what you mean?
Yeah. Yes.
Always start it the way it is. 4, then minus 2x, because this one will become just 4, then the 2 will come down, and then minus 1.
I can't say minus 2x plus 4.
Then you can actually say that, but it's neater to say 4 minus 2x.
Okay.
It's usually neater to write the positive term first. Now look at it. It says find the coordinates of the turning point of the graph y equal to 6 plus 4x minus x squared. Do you have any idea of this one?
Yeah, I don't really understand this one.
Oh, it's very easy. So I want to show you something. I'm going to go back to the previous page and create more pages so that we can discuss it first of all. So I'm on page 1 again. Oh, now I'm going to page 2. I've created another page. Now, first of all, gradient. You can use differentiation to find gradient. In fact, if you remember, let me add a background of a graph. If you remember, if we have this graph, I can even zoom it in to make it bigger. If we have this graph, you're seeing what I'm drawing? Beautiful. Just stay with me. We're doing it great. Sorry, let me make it lower here. See this graph? If I have this graph and a line runs like this, what's the gradient of this line? This is 1, 2, 3, 4, 5, and so on. 1, 2, 3, 4, 5, 6, 7, and so on. What's the gradient of this line? You know, gradient is rise over run, isn't it? Changing y over changing x, isn't it? You know,
Yeah.
gradient or slope? Gradient.
Sorry?
Yeah, gradient or slope is changing y over changing x, is it not? or let me write it like this, change in y over change in x,
over x2 minus x1.
or like y2 minus y1. That's a change in y, all over x2 minus x1. That's a change in x, which is simply change in y over change in x. So differentiation is a way we can use to find gradient. We can use differentiation to find gradient because gradient is change in y over change in x. You know, in economics, whenever you see this symbol, it means change. You remember?
Yes.
So dy over dx simply means change in y over change in x. So when you differentiate a function, you are basically finding its gradient. You are finding its what?
Gradient.
So differentiation is gradient. Dy over dx is gradient. Take note of that. In fact, if this line is y equal to f of x, you know, the gradient is dy over dx. The gradient will be simply dy over dx, which is changing y over change in x. What's the change in y? Rise over run. Let me draw it better so that we can write those gradients. What's the rise?
I'm not sure. 7?
Yeah, you're right. 7. What color can I use? Let me use yellow. 7 for rise. 4 for run. Am I right?
Okay.
7 over 4. 7 over 4. And it's a positive gradient because it's sloping upwards. If it was sloping downwards, it would have been a negative gradient. I hope you know.
Okay.
Alright, so rise over run is the gradient of changing y over changing x is the gradient of slope. And it's the same thing as the dy over dx. When you differentiate it, the function, you get the gradient. Now we're going to apply that further. I'm going to draw something else. Watch this again.
Number.
Are you still here?
Yes.
This graph I just drew here, what's the gradient of this line on the graph? Let me call this one. Okay, I can even write values. 1, 2, 3, 4, then 1, 2, 3, 4, 5, 6, and so on. This is y-axis. This is x-axis. What's the equation of this line, by the way? Do you know the equation of this line?
The equation of the straight line graph.
Yeah. That's what. It's simply the value of y here. So this line is y equal to 3. It's a graph of y equal to 3. Because the value of y there is what?
3.
Now, what I'm basically saying is this. Just listen to me. What I'm basically saying is this. Anytime a line is just horizontal, it is not sloping. It's not sloping upward, neither is it sloping downward. No steepness. Or is this line that I drew, this green line, is it steep?
No.
It doesn't have any steepness. In fact, slope or gradient is a measure of steepness. It's a measure of steepness. The other names we use for it: slope, gradient, steepness, tangent, rate of change. They are all measuring the same thing. The steeper the graph is, the higher the gradient. Let me draw another one to show you. Don't worry, all of these things will come together. I'm going to use a black line. Oh, what color can I use now? Let me use the green line to represent another graph. Look at this one. See this green line. What's the gradient?
The gradient is.
So I'm going to use red line to draw. Let me rewrite this with the red marker to write the gradient of the red line. Gradient of red line. You said rise over run, 7 over 4, isn't it?
Yes.
7 over 4. So what's the gradient of the blue line, green line?
7 over 2.
Gradient of green line, also rise over run.
7 over 2.
Yeah, you're right. 7 over 2. What's 7 over 2? 7 over 4 and 7 over 2, which one is bigger?
Sorry?
7 over 4 and 7 over 2, which one is bigger? By the way, this one
7
is...
over 2.
7 over 2 is bigger. 7 over 4 is 1 whole number, 3/4, right? Why this one is 2 whole number, 3 whole number, 1 over 2 over 3. So obviously the green one is bigger because it is steeper. Isn't it steeper?
Yes.
If you're climbing a hill like this, and your friend is climbing a hill like this, obviously yours is steeper. It will be more difficult to ride a bicycle up this hill. I said all of that to say this. The steeper the line, the bigger the gradient. Did you hear that?
Yes, sir.
Okay. Now, what about if the line is not steep at all? Like this line, I'm going to use a different color. I will call it this black line. Let me use blue. Blue, or no, black would be better. This black line, you know, it's not steep at all. It doesn't have any steepness at all. It's just like a flat surface. A line that is just flat, horizontal, has no steepness, so it does not have any gradient. So, gradient or dy over dx is equal to 0. Did you hear me?
Okay, yes, sir.
Why is it equal to 0? Why is it equal to 0? Why is it equal to 0?
Because it has no steepness.
It has no steepness, it's just a horizontal line. So, gradient of horizontal line is always equal to 0. Gradient of a horizontal line or a turning point is equal to 0. Turning point is obviously where the line touches a 0 position. Okay, let me explain. Let me explain what I mean. I'm going to draw this graph. Then I'm going to draw this one. Okay, I'm sorry, I took it too far. Let me make it different. I can just do something like this so it doesn't get too complicated. Okay, look at this. You know, if you remember your graph thing, if you have a graph like this, here is 1, 2, or let me just write 2, 4, 6, 8, 10, so that the marking will not be too much. 2, 4, 6, 8, then 10. Then you have 2, 4, 6, 8, and so on. Are you ready?
Yes, sir.
This is the x value, this is the y value. X value, y value. Now, if you're asked to find the gradient at x equal to 2, at x equal to 2, can you see where x is equal to 2? Did you hear me?
Yes, sir.
At x equal to 2, this is where x is equal to 2. Normally you will trace it up. You trace it up, dot, 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 dot. Wherever you get to the point, you make a big dot and draw what we call a tangent. A tangent. I'm going to use a green line to draw the tangent. A tangent is a line that touches that point in such a way that it's, no, this is not, I can draw a better tangent. It can be better. Okay, this one is not bad. This green line I drew is a tangent at x equal to 2. You can see where x is equal to 2, isn't it?
Yeah.
So normally what we do is, this, after you have drawn this green line, you can now find the gradient of this green line. If we can make it longer, I can easily find the gradient of that green line, assuming it touches here. What's the gradient of this green line?
It's over 4.
Do rise over run, no? How tall is this? How long it is? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It looks like it's 1. 1, 2, 3, 4, 5, 6.
Oh, we must stop where the tangent ends.
Yeah, you must stop. When you pick a point, like you started from here, you have to get to the end. Or if you start from a point, you need to go to the other point. Just start from one point to any other point.
Oh.
So this is what I'm saying. If you wanted to start from here to here, not a problem. To here, not a problem. If you want to start from the very end to this very end, not a problem. Why I chose it is so that I can have definite marks. It will be easier for me to count. So for the rise, I have 1, 2, 3, 4, 5. That's where it stops here. For the run, I have 1, 2, 3, 4, 5, 6. Did you get that?
Yes.
So the gradient at x equal to 2 is what?
5 over 6.
Alright, let me write it in green. Gradient at x equal to 2 will give us rise over run, which is,
5 over 6.
yeah, the x over the x is 5 over 6. Now what is the gradient at x equal to 5?
X equals to 5.
I'm coming to draw it so that you see. First of all, you trace x equal to 5. I'm going to use a different color. Let me use a black marker to trace it. You trace x equal to 5. This is where x is equal to 5 now, isn't it?
Yes, sir.
This point. You also draw a tangent at that point. You do what?
Draw a tangent at that point.
You know how to draw a tangent now?
Yes.
That's a
And
tangent.
that touches the
Yeah, the
arc
sec.
of the
Ah,
circle.
exactly. That's a tangent. So what's the gradient at this point?
The gradient at that point will be 0.
Interesting. It's 0 because it's a horizontal line. So gradient at a turning point is always equal to 0. That's what I wrote here. Let me show you. Gradient of a horizontal line or a turning point is equal to 0. So let me just write, whether it is at this point where it is also turning, or at this point where it is also turning, it's always equal to 0. Hear that again. Gradient at a turning point is equal to what?
0.
Alright, so gradient at x equal to 5, which is also the y over the x, is equal to 0. Gradient at a turning point is equal to 0. There's a slight mistake we made here. Actually, for this green line, rise over run will be from here to here. Rise will be 1, 2, 3, 4, 5, but the gradation is in 2s. So because this is 2, 4, 6, 8. So this will be 2, 4, 6, 8, 10. Rise is 10. And this needs to be corrected. Rise is 10. 10 over run. run is also from here. Let me count again. From here, 1, 2, or 2, 4, 6, 8, 10. For right, then for run, 1, 2, 3, 4, 5, 6. 6. So 10 over 6 is the gradient at that point at x equal to 2. Sometimes the turning point could be peak, what we call maxima. Some other time the turning point could be the valley, what you call minima. Maxima for the peak, minima for the base or the valley. How do we know whether a turning point is a peak or a valley? Like a crest or a trough, if it was physics. Now, we know that, are you listening to me?
Yes, sir.
We know that, oh, I think I need to use a different color marker. We already know that, A, if dy over the x is equal to 0, then it must be a turning point, is it not?
Yes, sir.
Do you agree with me?
Yes, sir.
Read what I wrote in yellow now.
We know that if dy over dx is equal to 0, then it is a turning point.
Alright, it's a turning point. Now, we need to know whether the turning point is a peak or a trough. So let me write another one. Now, if we differentiate it again, after we've done the first differentiation, if we differentiate it again, I will explain to you. If the squared y over the x squared is less than 0, then it is something. Let me write the other one before I conclude. C I can write this one in green. C, if the squared y over the x squared is greater than 0, then it is something.
Okay, so
I will tell you. I'm going to use an example to illustrate this. Let me show you. I'm going to use an example to illustrate this. I have 2x squared minus 5. Maybe, oh, it's too big. Let me. Example, y equal to 2x squared minus 5x. Let me see what I can use. 2 times 4 is 8. 8, 4, 2. 4, 2 is minus 6. So let me call this minus 6. Minus 6x plus 4. 2 times 4 is 8. 4, 2, okay. If y equal to 2x squared plus 6x, 2x squared minus 4 minus 6x plus 4. Now, let's first of all differentiate y. Are you ready?
yes, sir.
So dy over dx will give us what? 4x minus 6. Beautiful. What did I tell you dy over dx is?
dy over dx is gradient.
Beautiful. I'm so happy that you remembered immediately. Dy over dx is gradient. So what we just found is the gradient. That's the gradient. This is the gradient. That's the gradient. So when you differentiate it again, I'll try to show you the rules to know whether it will be a minimum or a maximum. We're going to use examples to illustrate this. When you differentiate it again, the squared y over the x squared means differentiate it again. If you get a value less than 0, then it is a maximum. I will explain with examples. It is a maximum, then it is a maximum. Let me write it below. Maxima is the peak, like the peak of the curve. But if you differentiate it again and it is greater than 0, then it is a minimum. I will explain it properly. We use examples. Alright, let's go back to that question that we're looking at. There was a question I were looking at and then I came back to here. This is it. It says, can you read it out?
Find the coordinates of the turning point of the graph of y is equals to 6 plus 4x minus x squared.
Yes, find the coordinates of the turning point of the graph. 6 plus 4x minus x squared. Turning point. Remember turning point, right? Okay, now we know that at turning point, the gradient will be what?
0.
Beautiful. So at turning point, the y over the x will be equal to 0. So do the y over the x.
Four minus 2x.
4 minus 2x. So since at turning point the y over the x is equal to 0, then we can simply say 0 is equal to 4 minus 2x. Did you see that?
Yes, sir.
Because at turning point the gradient is 0. Now solve this equation, 0 equal to 4 minus 2x. What does it give us? Let's solve it. 2x is equal to 4, isn't it? Or x is equal to 2. Am I right?
Yes, sir.
Just solving this equation. I hope you can solve this equation. It shouldn't be a big deal. Am I right?
Yes, sir.
Okay, please let me be sure you understood what I did. Did you?
Yes, sir.
Okay, so x is equal to 2. They ask us to find the coordinate. You know, when you are getting a coordinate, you need to get the x value and the y value. The x value and the
Y value.
So we found the x value. All we need to do is get the y value by substituting the value of x into this place. Substitute the value of x into where you have x. Did you hear me? Substitute. So we just carry out a simple substitution to find the value of y. We found the value of...
Sorry, sir. Mr.
Yes,
Can you explain something to me?
I'm listening.
When you did 0 is equals to 4 minus 2x, I don't know, from what I did, I got minus 2x is equals to 4.
Good. No, minus 2x is not equal to 4. You need to move the 4 to the other side. If you wanted to do it like that, minus 2x will be equal to minus 4 if 4 goes to the other side. You know, you left minus 2x here.
But if we carry 4 over, shouldn't that make it minus 4?
Yes, so what I expect you to say is minus 2x is equal to minus 4. Can we do it together?
Okay.
Let me use the black pen to do it the way you understood it. First of all, the equation is 0 is equal to 4 minus 2x. Can you see what I'm writing?
Yeah.
So what did you say we should do?
I said
we should carry the 4 over. Beautiful. So we carry the 4 over, it becomes minus 4 equals what?
Minus 2x.
Beautiful, minus 2x. So what do you do?
Then you do like minus cancel. Okay.
It's the same thing. Divide both sides by minus 2. So x will still be equal to minus 4 over minus 2, which will give you 2. So but actually what I did to make it easier was, since x is having a minus here, I just carried the x over. Minus 2x crosses over and becomes plus 2x. Do you understand?
Yes, sir.
Leaving the 4 here. So you have 2x equal to 4, or divide both sides by 2x equal to 2. Is it clear now?
Yes, sir.
Now they are asking us to find the coordinates. And you know, for coordinate you need to find both the x value and the y value. They need us to find the x value and the y value. We found the x value to be 2. What do we do to get the y value? Substitute this x value into this original equation, okay?
Yes, sir.
So let's go. You know y is equal to this. Y is equal to 6 plus 4x minus x squared. The original equation is where you are substituting it. So y will now be equal to 6 plus 4 times 2. You know what I mean by substitution? Substituting.
Yes, sir.
So 4 times 2. Just all of that will be replaced by x. Minus x squared will now be 2 all squared. Everything is written the way it is. 6 for 6, plus 4 for plus 4. Only what changes is only x. X becomes minus 2. Minus x becomes minus 2. Then squared. That's just substitution. So that gives us what? 6 plus. What is 4 times 3?
6 plus 8.
Minus 4. That gives. That's 10, am I right?
10. Yes, 10.
So x is 2 and y is 10. Therefore, x is 2 and y is 10, isn't it?
Yes, sir.
That means the coordinate will be 2, 10. You know, when you are stating coordinate, you write both the x value and the y value.
Yes, sir.
The coordinate is 2, 10. Is that understood?
Yes, sir.
Yeah, beautiful. So let's go to the next one. Read this out.
Calculate the gradient of y is equal to 24 plus x minus x squared, and x is equal to minus 1.5.
Beautiful. At x equal to 1.5. Gradient, remember gradient is the y over the x, isn't it?
Yes, sir.
So the y over the x will be equal to what? Let's get the dy over the x.
5 minus 2x.
5 minus 2x. Then it says at x equal to this, so you just substitute this with x. And you get the answer. So at x equal to minus 1.5, you just substitute. It's going to be 5 minus 2 brackets
Okay.
minus 1.5. Do you understand?
Yes, sir.
That gives us what?
Minus 3.
Okay, so this is equal to 5 minus, no, it's not minus 3, minus 2 times minus this will give us plus 3. Be careful. Minus 2 times minus 1.5 is plus 3.
Yeah.
So 5 plus 3 is 8. You really need to be careful about stuff like this. Okay?
Yes, sir.
So the gradient is equal to 8. Is that clear?
Yeah.
The simple thing is, say, calculate the gradient. So the gradient is just the y over the x. And at whatever it is, substitute it with that. Next question. For the curve with the equation this, find the y over the x. That's very easy. The y over the x is simple, this, isn't it?
Yes,
That
sir.
will be 4x, because 2
4x
times 2, okay.
minus 6.
minus 6. That's all. What else did they say we should do there? There's another question. Find the coordinates of the turning point, of the points on the curve where the gradient is equal to 2. Where the gradient is equal to what? 2. We have found the equation of the gradient. What's the equation of the gradient? 4x minus 6, isn't it? Good. 4x minus 6. And it says where the gradient is equal to 2. First of all, gradient, which is dy over the x, we have found it to be 4. What do you say it is again?
4x minus 6.
Yeah, 4x minus 6, yeah. 4x minus 6 is 4x minus 6. And then it says where the gradient is equal to 2. Where the gradient is equal to 2. Where the gradient is equal to 2. So where all this is equal to 2. That will now give us 4x minus 6 equal to 2. Did you see that?
Yes, sir.
Because it says where the gradient is equal to 2. Because that's the gradient. That's the gradient. The y over the x is the gradient. So where it's equal to 2 means this thing we got for the gradient equal to 2. So you just solve the equation. This is beautiful. Isn't it cool?
Somehow.
You're going to listen to this again. It's recorded. So this is equal to 2 plus 6. So 4x will give us 8, isn't it? So x is equal to 2. But it's asking for the coordinate. And you know coordinate has to do with both x and y. Whenever you do this, remember that you still need to find the y part. You are just going to use these two to substitute into the main equation, isn't it?
Yes.
What's the original equation? Y equal to 24 plus 5x minus x squared. The original equation was y equal to 24 plus what again? 5x minus x squared. That was the original equation. So just substitute 2 into all of this. Substitute 2 here and 2 here. Am I right?
Yes,
To get the other value of y. So y will now be equal to 24 plus 5. Then you open a bracket, 2, then minus 2, all squared. Everything written the way it is just the x that is replaced. You get what I mean? So this gives us 24 plus 10 minus 4, am I right? 24 plus 10 is 34 minus 4, that's 30. That's 30. Therefore the coordinates will be what? We found the y. So x is 2 and y is 30, isn't it? So the coordinate will be x 2, 30. Am I right?
Yes, sir.
All right. Next question. No, go to the next. Okay, I'm here. Okay. Okay. This question requires us to find the nature of the turning points at y equal to 2x cubed over 3 minus 3x squared plus 4x. Find the nature of the turning points. Now, for the turning point, the gradient is equal to 0. So we know that at turning point, gradient equal to 0. At turning point, gradient equal to 0. So if gradient is equal to 0, what we need is to find the gradient of that. So dy over the x we need to get dy over the x of that function, and that would be 3 times 2 then over 3x. Then we move, that's 3 comes down, 3 times 2, that's 6x over 3, then minus to that. We remove 1 from the power of 3. That gives us 6x squared over 2 over 3 rather. Remember the general rule. The general rule is if y equal to ax raised to power n, dy over the x is n comes down to multiply a, and then we remove 1 from the power of n. That's the rule I'm applying here. 3 comes down to multiply this coefficient, so 3 times 2 over 3, which is 6 over 3, and we remove 1 from power of 3. So that gives us 6x squared over 3. We apply the same thing here. 2 will come down to multiply 3, and that will give us 6x, because after we remove 1 from the power of 1, x, it will just be 6x. So this is minus 6x, then this one will just be plus 4. When we simplify, we're going to have the y over the x to be 2x squared minus 6x plus 4. Two x squared minus 6x plus 4. This is the y over the x. At turning point, the gradient is 0. So this gradient, this is the gradient, which is the y over the x, is equal to 0. So at turning point, at the turning point, this gradient is equal to 0. In other words, 2x squared minus 6x plus 4 is equal to 0. That forms a quadratic equation. We can solve the quadratic equation to get this. To get simple solution of quadratic equation, we'll be able to get x minus 1 into 2x minus 4 equals 0 by factorization. We can factorize this to get x plus 1 bracket 2x minus 4. By the way, if we needed to expand further how we came about this, I can just show that, you remember we usually multiply 2 by the coefficient of x by c. 2 times 4 is 8. Factors of 8 are 4, 2, 8, and 1 itself. 2 factors of 8 such that sum will be minus 6, product will be plus 8, minus 2 and minus 4. So this would have been 2x squared minus 2x minus 4x plus 4 equals 0. By factorization, we just substitute these 2 factors that satisfy the condition. We replace them with minus 6 with them, and of course this will just become, without wasting time, this will give us what I wrote earlier, which is x minus 1 bracket 2x minus 4 equals 0. And this gives us 2 values of the turning point. X is equal to 1 or x equal to 2. Two values of the turning point will be here. x equal to 1 or x equal to 2. So we have found the two values of x where there is a turning point, where the gradient is 0. Now we need to know which one is which, because it could be a maxima for a peak or a minima. But we know the 2 points where there's a turning is x equal to 1 or x equal to 2. And we just need to know which one is which. To do this, we differentiate again. We differentiate this y again. In other words, the squared y over the x squared will give us, differentiating this again, this is the first differentiation, this is what we got, 2x squared minus 6x plus 4. So let's differentiate this again. Differentiate this again the second time. That's the squared y over the x squared. When we differentiate this again, we're going to have 4x minus 6. 4x minus 6 is what we get when we differentiate it again. The squared y over the x squared will give us 4x minus 6. This is what I differentiated again. 2 we multiply to, that's 4x. Then this is minus 6. The constant disappears. So the squared y over the x squared will give us 4x minus 6. Now we just need to test. Remember, if the squared y over the x squared is greater than 0, then it's a minima. It implies it's a maxima. No, if it is greater than 0, then it's a minima. If the squared y is less than 0, it's a maxima. If the squared y over the x squared is less than 0, then it's a maxima. So all we need to do is to substitute these two values. Substitute x equal to 1 into this and x equal to 2 into this, and see the values we get. So let's start first of all with x equal to 1. We substitute these two values of the turning point, the x values of the turning point, into this second derivative. After we differentiated the first time and we differentiate the second time, we substitute x equal to 1 and substitute x equal to 2 into this equation of the second derivative, and see the one that will be greater than 0 or less than 0, so that we know whether it's a minima, the trough, the valley, or maxima, the peak. So starting with x equal to 1, let me zoom in a bit. So when x is equal to 1, let's see. When x equal to 1, let's put it into this value. We're going to have the squared y over the x squared will be equal to 4 opening bracket 1 minus 6. 4 opening bracket 1 minus 6 will give us minus 2, which is a minima. Minus 2 is, by the way, minus 2 is less than 0, so it's a maxima. So at x equal to 1, it's a maxima. This is a maxima. That point is a maxima because we found x to be minus 2, which is less than 0. So it's a maxima at x equal to 1. Let's look at the other one. When x is equal to, I think I better write this with well, it doesn't really matter. The second one, when x is equal to, let me write, okay, when x is equal to, the second one is, there are two values of x for 1 and 2. Let's check for when x is equal to 2. When x is equal to 2, let's find the squared y over the x squared will be equal to, we substitute into this second derivative, 4x minus 6. So we have 4, open the bracket, 2, then minus 6, because x is equal to 2 at this point. And that will give us 8 minus 6, which is 2. This is 2, and 2 is greater than 0, so it is a minima at that point. This implies minima. So that means, while we have this, we have found out that there's a turning point at x equal to 1 and x equal to 2. We have also shown that at x equal to 1, the turning point is actually a maxima, it's a peak. At x equal to 1, it's a peak, maxima. Because this differentiating it again gave us something less than 0. Less than 0. That's minus 2. When we differentiated it again and substituted x into that equation, we got less than 0, minus 2. So it's a maxima, it's a peak at x equal to 1. Now at x equal to 2, the second position of the turning point on x, we differentiated it again and then substituted x equal to 2, and we got 2, which is greater than 0. And when it's greater than 0, it is a minima. So there's a maxima at x equal to 1, and there's a minima at x equal to 2. That's how we do it. Okay, this one says, let me zoom it in a bit. It will be, a curve has equation y equal to x raised to power 3 plus 7 over x squared minus 2x plus 9. Find the y over the x. Can we do that very quickly? Are you ready? The y over the will be equal to beautiful. 3x squared.
That's 7 over 2x squared.
Yeah, 7 over 2x squared. That will now be
4x.
Remember, it has to be 7 over 2
7
times 2 and then x. Because the 2 up will come down and multiply the coefficient of x. Just like the 3. What's the coefficient of x cubed here? 1, you're right. That's why we multiply 3 by 1. We have 3. Then we remove 1 from the 3. That's 2. 3x squared. That's always the rule. The rule is you take the power and multiply by the coefficient of x. So 2 times 7 over 2 will give you what?
2 times 7 over 2.
Or 7
over 2.
No, times 2.
Sorry,
7 because 2 will cancel out. Then these 2, you subtract 1 from it, isn't it?
Yeah.
Okay. So minus 2x. Differentiate minus 2x. What do we get?
Minus 2.
Minus 2. 9 clears out, isn't it?
Yes, sir.
So this gives us...
Please, can you remove that? I'll write this down.
Okay. So on the Jamboard. Alright, so 3x squared plus 7. Am I right? 7x
Yes, sir.
minus 2. Because this 2 crosses out this 2. Am I right?
Yes, sir.
So that's the y over the x. dy over dx will give us this. The rule always is the power of x, multiply it with the coefficient of x. That's why we have 7 over 2 times 2. Then the power of x, subtract 1 from it. 2 minus 1 gives x raised to the power 1, which is just x. 2x will just be 2. X cubed will be 3 times the coefficient, which is 1 here. 3 times 1 is 3. Then 3x squared. Okay, so that's dy over dx. What's the next question? It says find what?
The gradient of the curve
At the
point where x is equals to minus 3.
Beautiful. By the way, the gradient is, you know, the gradient is dy over dx, isn't it?
Yes, sir.
All right. Remember, gradient is dy over dx, which is all these things we found. 3x plus 7x minus 2. So you say where x is equal to minus 3. So we just substitute minus 3 with all this. That's all. Just substitute minus 3 with here, that's all. You know. So that would be equal to, that will give us 3x, 3 open a bracket, minus 2. You need to be careful.
6.
That's minus 3 rather. How did you get 6? That's times 3.
No, I did everything on the calculator.
Oh, better. It's actually better. It's better. 7, okay, it's better. So we don't waste time. Let me just write it down. Minus 3, then minus 2. Alright, so you're right. This should be minus 9 plus, no, minus 21. You were not careful. Minus 2. How do you get what you got? Is that 3x squared?
Yes, it's 3x squared.
Oh, 3x squared, sorry. I forgot the square when I was writing the last thing. So this should be squared. I'm sorry, that's probably why we missed it. This is squared. dy over dx is 3x squared plus 7x minus 2. 3x squared plus 7x minus 2.
Minus 2.
Okay, so this will now be plus 9. It's not even 9.
And then the overall.
This is 27. You are right. Because minus
Yes.
3 times 2 is 9 times 3, that's 27. 27 minus 21 is
6. And then minus 2 gives me 4.
4. Okay. So the answer is 4, right?
Yes, sir.
It's 4. Okay. Don't bother about this one. It's the same thing. You just substitute. Substitute and get that. Can we just leave it?
Okay, sir.
Let's just leave it and go to the next. I think there's a question here. It says something. What can you say about the tangents to the curves at these 2 points? In fact, the equation of the tangent is the equation of the gradient. Did you hear me?
Yes, but I don't understand.
Yes, I will explain. I would have skipped this question. I didn't know. I would have probably forgotten it if it hasn't come up. Just like all the things I explained to you earlier, assuming this is minus 1, 1, 2, 1, 2, 3, 4, 5, 6, 7, and so on. Then you have 1, 2, 3, 4, and so on. At every given point, like x equal to 1, just like I explained to you earlier, at x equal to 1, if you want to find the gradient at x equal to 1, what do you draw?
At x is equals to 1.
If you want,
Draw a tangent.
you draw a tangent. So let me draw the tangent properly. Tangent at x equal to 1. Tangent.
Can I do the tangent facing upward?
How do you by facing upwards?
You know you drew the tangents from 3 to 2. What
No,
if
I didn't necessarily draw it from 3 to 2. I was drawing it in such a way that it must touch where x is equal to 1 in like an arc. It must touch x equal to 1. It can come from any, it can be as long as possible. I can make it much longer on both.
No, it's not about the length. Can I do it like maybe from 3 to minus 2?
3 to minus 2, like, you mean if it is going this way?
Yes.
If it's going this way,
Yes.
then it's no longer a tangent because it must touch the arc. It's like it must actually make contact with the arc, not cross it. It must make contact with the arc.
Okay.
If you draw it like this, it's no longer a tangent. The tangent has to make contact with the arc at the given point. So I'm trying to tell you that the equation of the tangent is the equation of the gradient. Anyway, we will solve a question to illustrate this. Let me go forward. I think I should have something. Let's go to this question. I like this one. It has something that will explain this. Can you read it?
The diagram shows a sketch of the curve y is equal to x squared plus 3x minus 4. Differentiates y is equal to x squared plus 3x minus 4.
Okay, let's do that very quickly. The y over the x gives 2x plus 3. Good. It says find the equation of the tangent to the curve at the point 2, 6. All right.
So that means I'm finding the equation of the gradient.
I'm coming. Just a moment. At the point 2, 6, where x is 2 and y is 6. Where x is 2 and y is 6. Okay. So the equation of the tangent at any given point is the equation of the line drawn to find the tangent at that point. You know? For instance, at x equal to 1, the equation of this tangent at x equal to 1 is the equation of this line drawn to find the gradient at x equal to 1. In other words, the equation of this green line is the equation of the tangent, because the green line is a tangent. So take note of the fact that the equation of the tangent at any given point is the equation of the line drawn to find the gradient at that point. You know. So we have found the questions I copied are just very nice questions. They will explain all this very well. We have found the gradient to be this, 2x plus 3, right?
Yes, sir.
And then it says find the equation of the tangent at the point 2, 6. 2 is the value of x, is it not? Y 6 is the value of y. Do you know?
Yes, sir.
6 is the value of y. So if 2 is the value of x, what is the gradient? Did you hear me? What's the gradient? You're just substituting 2 into here now. Substituting 2 where you have x to get the value of the gradient. Did you hear what I said?
So, do we substitute it to the old equation or the new equation?
This is the equation of the gradient. You are substituting into the equation of the gradient. That is the equation of the gradient. you're substituting it into here too. If you substitute it into the old equation, what you are getting is the value of y. Anytime you are substituting into the old equation, you are getting the value of what? Y. So we need to find the gradient at x equal to 2, because it's asking us, the point is where x is 2 and y is 6. You will see how all of these things come into play. So at x equal to 2, the gradient is what? Remember, this is the gradient. This, the y over the x, is the gradient. At x equal to 2, the gradient will be what? 2, open a bracket. 2
plus 3.
Yep. 2 bracket 2 plus 3. Yeah. Plus 3. And that gives us what? 7. Am I right? Good. So the gradient is 7 at that point. So rise over run is 7. Gradient is 7. Remember, y is equal to mx plus c. You know this? That's the equation of a straight line. What does m stand for? What does m represent? Gradient. M represents gradient, C represents intercept. C stands for intercept. M represents gradient. M stands for gradient. C for intercept. So what we just need to do is find the intercept, and then we just plug back the values. Let me say this properly, you will get it. It's very easy. Watch me. We found the gradient to be what again?
7.
Good. So we are plugging in all of this into this equation, general equation of a straight line. This is the general equation of a straight line, y equal to mx plus c. Have you not come across this before? Yeah, y equal to mx plus c is the general equation of a straight line. We are plugging in these values into the general equation of a straight line, and I said m stands for the gradient. M is the gradient, so we are representing m with 7. X, we use the value of x. What's the value of x there? 2. Y, we use the value of y there? 6. So let me write it down again. At 2, 6, let me see the way I can write it so I can show you this. When you are reading it, you understand with it. At 2, 6, remember the 6 will go to y, while the 2 goes to x. Substitute all of those values. So we're going to have, this gives 6 equals, y equals, so it becomes 6 equals, m is what?
7.
So 7 times x. X is what?
2.
X times 2. Plus c. We don't know what c is, so we can just use this to find c. So 6 is equal to 14 plus c. What's c? 6 minus 14, which is minus 8. 6 minus 14 is 8. You can solve it in your own way. Just leave c here and take 14 across. It becomes 6 minus 14 minus 8. Am I right? Are you trying to see how you can solve this?
Yes, sir. Hold on a minute.
Yep. Okay.
Okay. Carry on, sir.
I should carry on?
Yes, sir.
Because if 14 crosses over, it becomes 6 minus 14. So c is minus 8. All we are trying to do is to get C. And once we've gotten C, we write out these values again, substituting M and C, leaving the rest. So I will just write the final thing. The equation of the tangent will now be equal to, it's going to be an equation. All other things will be written left the way it is. We're only going to substitute M and C. M and C. Y will still be Y. X will still be X. Only M and C to get an equation. So Y will be equal to, what did you get for M? I will run through this for you to understand again. What do you get for M? 7. Are you still there? 7x. What did you get for C? Minus 8. So this is the equation of the tangent. Okay, you said you still remember how I did this one to get the equation of the tangent. But I think what I'm saying is there's an easier equation you can use. Instead of having to find C, you first of all find C and then you substitute to get the main equation of the tangent. The simplest equation is this. Read it out. Read out the equation. Can you read out the equation?
Y minus y1 over x minus x1 is equal to m.
Is equal to m. The y1 and the x1 are the coordinates. In fact, that's the y1, x2 is the x1, 6 is the y1. So we just substitute them into this equation. 6 is the y1, 2 is the x1. Of course, the intercept is 7, You remember?
Yes, sir.
Okay, so we just substitute. Let's do the substitution again. Y is equal to y minus 6. Okay, let me write it with a black pen. Y minus 6 over x minus 2 is equal to 7. Am I right?
Yes.
It's like saying 7 over 1. So you cross multiply. Cross multiply. This times this. What is y minus 6 1?
Y minus 6.
Exactly, that will still give you y minus 6. So this is y minus 6 equal to, what will be 7 times this? That's like saying 7 open a bracket x minus 2. Is it not?
X minus 2. Yes, sir.
7 open a bracket x minus 2. That's 7 times this. So that gives us y minus 6 is equal to, open a bracket, you have 7x minus 14. So just simplify, because the general equation of a straight line is y equal to mx plus c. What I'm asking is simplify it so that you look like, or simplify it in the form of the general, simplify it to the form of the general equation. Of a straight line. General equation of a straight line. Which is y equal to mx plus c. All you need to do is let y stay alone, or make y the zeta formula. So y staying alone will now be y equal to, all this will go to the other side. Remember, I said just simplify this so that it will look like this. So let y stay alone, make y the zeta formula, y stays alone, every other thing goes to the other side. So you have 7x minus 14, then minus 6 crosses over, becomes plus 6. So that gives you what? Y equal to 7x minus 8. And that was the original, this first thing we got. So whichever method you use, you get the same answer. That was what we got initially. Y equals 7x minus 8. That's the equation of the tangent. But I think this formula will be easier for you to remember. But you need to memorize it. Y minus y1 over x minus x1 equal to n.
Yes, sir.
Okay, I think that's cool.
Please don't forget to like, subscribe, and comment. Thank you so much.
Welcome to Like Learning School, your premier online education platform. At Like Learning School, we are dedicated to helping students and learners unlock their full potential, providing them with the foundation, support, and guidance they need for academic excellence. Our platform caters to two main target audiences. Firstly, we work with school children of all ages, offering academic follow-up and accountability partnerships. Our seasoned tutors provide personalized attention to ensure students stay on track and reach their goals. Secondly, we support students and learners who are preparing for internal, external, entrance, or professional examinations. We offer comprehensive and well-structured support to help them achieve outstanding performance in their exams. Our robust virtual courses are designed to keep students engaged and motivated. With interactive videos showcasing our teaching sessions, students actively participate in the learning process, making education enjoyable and effective. But that's not all. We believe in personalized education. Our students have access to personalized tutorial sessions, whether online, physical, or hybrid, tailored to their unique learning needs. Join us at Like Learning School and experience a transformative education journey. Visit our website at www.likelearningschool.com or contact us at +234 808 509 5144 to learn more and get started today.